Hello friends, welcome to my channel Technical ArCoAn. Today I am going to show you shortcut methods of number system conversion. So go for it. This table actually shows the shortcut method when we convert from one number system to another number system. I am already discussed from standard number system to any number system how we can convert, and also from other number system to the standard number system how we convert. Now the shortcut method for any number system to any number system, how can conversion is going on. Okay, so this table should you remember. So there we given the decimal number from 0 to 15 and equivalent hexadecimal number of that. The similar from 0 to 9, but from 10 to 15 we know it will represent by A, B, C, D, E, F. Okay, and octal we have only the 8 digits from 0 to 7. Now this column represent binary equivalent of octal in a 3 digits. Means 0 is representing by 000, 1, 001, and the same manner up to 7. And the last column represent the binary equivalent of hexadecimal number in a 4 digits manner. Means when hexadecimal 0, it should represent in 0000, means 40 we are using. Suppose we take 9 for hexadecimal, so equivalent binary should be 1001. For F, it should be 1111. Okay, so go for an example. Now the shortcut method when we convert from hexadecimal to octal, so what the first procedure? The procedure that I am just writing the number AF.15. Okay, now we are just write the equivalent binary of this hexadecimal number. Okay, so what is the equivalent binary for F? It will be 41. So we are right there 41 at first. Okay, and put the point here, whatever the point is there, and after that we write the equivalent binary of the number A. So what is the equivalent binary for A? 1010. So here we write 1010. Okay, the same manner the fraction part will be do in the same way. So 1, what will be the binary equivalent for hexadecimal number? 0001. So we are write 0001. Okay, next the 5. So the equivalent of 5, the binary equivalent is what? So binary equivalent of 5 will be 0101. So we write here 0101. Okay, so we complete the writing. Now it convert in octal. So what happened in octal? The grouping form in a 3 digits. In hexadecimal, the binary equivalent grouping is done 4 digits, but in octal the binary equivalents are formed in 3 digits. So in case of octal, the binary equivalent form using 3 binary digits, means the group will form using 3 binary digits. Okay, and for a fraction is concerned, we take from right to left. The group will be formed from right to left, and for the after the fraction the group form from left to right. Means the fraction part will go from left to right, and the from after before fraction the group form from right to left. So there is a 3 digits, the one group, there is 3 digits, the one group, and there is a 2 digits. So that's why we put a 0 and form a single group. Okay, and the same manner they have the 30 is a one group, next 101 is a 3, so that's why it's one group, and after 01, so we need to put a 0 after that, and it will form another group. Now we put the value of this equivalent binary digits in octal. So 010, so what will be that? 010, the value in octal will be 2. So that's why we write here 2. Okay, and after that 101, so 101 will be the 5. Okay, and 111 it will be the 7. So 101 will be the 5, and 111 will be the 7. Okay, and after we put the point, and 000 means we already know it is 0. How? This 0 will be 000, and 101, what will be that? It will be again 5. Okay, and 010 will be 2. Okay, so this will be your result, and we put here in octal, means base will be 8. Okay, now we convert from octal to hexadecimal using shortcut method. So we first write the number 752.17, and we write the binary equivalent of this octal. Okay, so what will the binary equivalent? First we put this decimal and we write from right to left here, and after that we write left to right. Okay, so what will be the equivalent of 2? So what will be the equivalent of octal? 2 will be 0 1 0. So we write here 0 1 0. Okay, now after that a 5 will be there, so 5 will be this octal. So what will be the equivalent? 101. So we write here 101, and after that what will be the 7? Equivalent of binary will be 111. Okay, and after we put the decimal, and what will be the equivalent of binary of 1? So 1 will be 001. So 001, and what will be the 7? 111. Now it convert into hexadecimal, and hexadecimal binary equivalents form 4 digits in a group. Okay, so that's why we take 4 digits to form a group. Before decimal we take from right to left, so these 4 will take a single group. After that these 4 will be taken a single group, and after only the 1 digit, so that's why I am putting 3 zeros there, and it will form another group. Okay, and after decimal there 4 will be form a single group, and after present only 2 1, that means 2 digits, that's why you put 2 0 here, and it will form again the another group. Now we put the value, means equivalent binary. What will be the hexadecimal number? So 0001. So what is the result of 0001? So it will be hexadecimal is 1. So I am putting here 1. Okay, and after 1110, so what will be the 1110? It will be the E for hexadecimal. Okay, and what will be the 1010? 1010 will be A, so we write here A. After put decimal, what will be 0011? 0011 will be the 3, so we write here 3. And what will be 1100? 1100 will be your C, so this will be converted into hexadecimal. Okay, in the same manner we can convert from decimal to hexadecimal, from binary to hexadecimal, from octal to binary, from decimal to binary. Okay, so this is a shortcut method, and which represent using this table, where this 5 column is most important. Means using this 5 column we can convert any number system to any number system. Okay, I hope you have understood this topic. For more updates, keep watching my channel. Thank you.